Good afternoon, everybody. Thank you so much for joining us today for this seminar presentation. This is a little bit outside our regular seminar series, but we are very happy to have Dr. Shoaib today to give us a presentation about Center for Precision Agriculture, PMAS, Arid Agricultural University. We have been trying to establish some collaboration between TREC and his institution. And this presentation, I hope, will give faculty and staff at TREC and at the UF, hopefully, some idea what kind of research activity and potential collaboration could be, established between these two institutions. So Dr. Shoaib has been working as an assistant professor in the Faculty of Agricultural Engineering and Technology in the PMAS Arid Agriculture University in Pakistan since 2022. He is currently the director for the Center for Precision Agriculture, C4PA. He got his master's in precision agriculture from Dalhousie University in Canada. His master's work was on variable rate fertilizer application in wild blueberry fields. After completing his master's, he worked as a research associate in the precision agriculture program at Dalhousie University, and his work focused on developing smart innovative technologies such as spot-specific sprayers and testing and evaluating various variable rate technologies in wild blueberry fields. He got his PhD in environmental engineering from the University of Gulf, and his PhD research focused on evaluating the impacts of pest management practices on groundwater quality in southern Ontario. After his PhD, he joined PMAS AAUR as project director for data-driven smart decision platforms. His responsibility focused on developing precision agriculture technologies for various cropping systems in Pakistan. Over the past decade, Dr. Shoaib has been working on sensor and control design and hardware and software development for machine automation, employing machine learning and deep learning models for real-time chemical applications. He has also made significant contribution to groundwater and surface water modeling, as well as the design and testing of high-efficiency irrigation systems for precision agriculture. As the director of Center for Precision Agriculture, he is committed to advancing precision and digital agriculture technologies and mentors numerous students and researchers involved in this program. Dr. Shoaib has published over 20 papers and abstracts in international publications, presenting his research at conferences worldwide. With that, I would give Dr. Shoaib to, I think he has already shared his screen, just take it away when he's ready, Dr. Shoaib.
Thank you very much, Dr. Hemant, for introducing me. First of all, I would like to thank everyone at TREC and University of Florida for providing me the opportunity to talk about the Center for Precision Agriculture and the scope of precision agriculture in general in Pakistan, and then possibilities for collaboration with the University of Florida faculty. So, as Dr. Hemant already mentioned, I am Director, Center for Precision Agriculture, and today I am going to introduce about the different labs that we have established at the Center for Precision Agriculture. And I would start by introducing about the university. So PMAS, Arid Agriculture University, is situated in Rawalpindi near the capital Islamabad. And we since we are close to the capital, so most of the policy makers and decision makers who are like are like in capital in Islamabad. So it's good for us to have established a center here in the near the capital so that we can provide some of the policy guidelines to the uh, government of Pakistan as well. So the overall mission of the university is to develop human resources through quality teaching, to ensure the food security, sustainability through technology development for value addition, especially in the dryland agriculture. So since we are in the arid region of Pakistan, so Pakistan is divided into different agroclimatological zones, and I will briefly outline that we have two separate or distinct zones in terms of irrigation. So one is non-irrigated areas, we call it like arid regions. And then we have the irrigated land, largest irrigated network in the world. And so our university is mandated to conduct research and technology development, especially focusing on the arid region, but we are also working in the irrigated lands as well. So we have about six faculties: Faculty of Crop and Food Sciences, Faculty of Forestry, Veterinary Sciences, and then Agriculture Engineering, and then the Faculty of Social Sciences. We have three major institutes: University Institute of Management Sciences, UIIT, Information Technology, and University Institute of Biochemistry and Biotechnology. And then there are new institutes in terms of the conducting the research related to agriculture, which is Institute of Food and Nutrition Sciences, Institute of Geoinformatics, Hydroponics, Soil Sciences, and then Women Development Center. And recently, quite recently, we have established some of the centers in which our center that I am going to present today is one of the new initiatives in the last 3 years. And then we have the China Park sub-centers and Cooperation Center as well. So in terms of student, we have about 16,000 students, and graduate students about 2,500, and PhD students about 800 or 750. So we have over 200 PhD faculty, which who are teaching in different disciplines, and most of them are graduated from abroad. In terms of their expertise, they are expert in different agriculture faculty or sub departments like agronomy, horticulture, and other allied disciplines. So, just to briefly talk about the challenges that we are facing in agriculture, especially, it's common like globally, but since Pakistan is one of the major, uh, uh, like one of the fastest growing population in the world, and in terms of in terms of food or cereal production, Pakistan's reliance is mainly on wheat crop, and then we are also relying on rice as the staple crop for some of the regions. And the challenges that are associated with the agriculture sector is global warming, of course. Pakistan is one of the worst hit region in terms of global warming, and then poor management practices that led to environmental degradation and also to the high cost of production, and high food prices are one of the challenges. In terms of rural population, our population is declining or moving towards city, and there is land and soil quality issues, and also lack of interest of youth due to the conventional practices. So why we need precision agriculture? So as I mentioned earlier, Pakistan is one of the region that is like we are still sticking with the technologies that are in most of the developed countries are obsolete right now. So about more than 90% of the farmer community is depending on these practices or still using these practices. Although we are sufficient in terms of producing our food, but since we are in terms of climate, we are blessed with the three cropping seasons. So uh, the agriculture that plays a significant role in terms of GDP, about 26%, and then the 70% of population is linked with the agriculture. So we we have to adopt these modern technologies for the better nutrient management, better irrigation practices, and then how we can reduce the cost of production and increase the farm profitability, and in terms of saving the environment or environmental pollution, since we are one of the worst hit country by the climate change and global warming. So precision agriculture is already a buzzword. Most of the developed countries are adopting these practices, and it is growing at a faster pace. And now, due to forcefully or due to the interest, the developing countries are also taking initiative to for some of these technologies, and we are in Pakistan recently, after the establishment of this center, government has also shifted the interest, and we have recently established SIFC, which has a mandate or a special focus on agriculture, and they are also uh, using precision agriculture technologies and propagating these technologies across Pakistan. So what led to the establishment of this center was that we were in back in 2018 we started working on this pilot project called data driven smart decision platform, and then the national agencies such as Sparco and also Pakistan Air Force, like through NASTAP, uh, they collaborated with us in terms of indigenizing some of these technologies. So these projects, the since we had a lot of funding and we were focusing on developing these modern technologies, so our ex-vice chancellor, Professor Dr. Kamuzaman, who is professor at Dalhousie University right now, he gave the idea or envisioned the ideas to establish this center back in 2022, late 2022, and we uh, we established this center and with the many labs. So I will present those labs in a moment. So His Excellency President of Pakistan, Mr. Dr. Arif Alvi, inaugurated this in January 2023, and we are mainly focusing on different aspects of precision agriculture technologies such as digital agriculture, precision agriculture, and then the crop system modeling. So our mandate is to develop these innovative technologies and then through the industry propagate these technologies to the farmer, and then provide the policy guidelines and some of the regulatory frameworks to the government to implement these technologies across the farming community throughout Pakistan. And uh, to start talking about the Center for Precision Agriculture Labs, we have six major labs that we are working, starting from sensors and variable rate technology lab. Then we have the UAVs lab, then the mechatronic and robotic lab, digital agriculture lab, big data monitoring station, and then the soil and crop monitoring lab. So we have two smart farms that we have established so far in Pakistan, and we are working with various farmers to implement these technologies or sensing technologies, and then we are linking these farmers with our center. So just to start with the sensors and VRT lab, the scope is to develop the VRT systems and then integrate different sensing technologies and indigenizing the already existing machineries that we have with the our agriculture machineries with the sensing technologies so that we can make them spot specific or variable rate. So, and then we have the UAVs lab. The Dr. Mohammed Naveed Tahir is taking lead of this lab, and the main mandate is to implement the UAVs, not only the spraying technology, but also the crop monitoring, and then the fertilizer technology through UAVs, and then implement some of the AI solutions through UAVs in agriculture sector. Then we have the mechatronic lab, and again we are working on robotic arms, then seed depth monitoring system, and some of the robotic solutions and the control environment solutions for the agriculture sector. Digital Agriculture Lab is led by Dr. Tahir Iqbal and Dr. Muhammad Akib, and their main focus is on developing digital libraries and then smart applications for disease detection and identification, and then developing some of the smart sprayers, AI-based sprayers for pest and weed detections. And then the soil monitoring lab is led by Dr. Muhammad Usman and Dr. Muhammad Veedanjam, and their lab is working on uh, zone management and then smart or precision irrigation technologies and looking at the how the climate change is impacting the soil and crop quality and yield. And then we have the established Pakistan's first big data agriculture monitoring station, and with the mandate to develop the smart farm and integrate the farming community through at one station where the all the repository from these different sensors from these farmers will come, and then we can provide the services to the farmers to apply the nutrients and the different irrigation practices using the AI models that we have established, and we are in process of establish some of these models. So here are some of the patents that we have filed so far through our center, starting from DASOS, which is the automated spray, and then the height monitoring devices, soil monitoring rig, and then the phenotyping cart and spreading system, and then the soil moisture sensor. So some of the highlights of the technologies that we have established, we are in process of establishing, indigenizing in our center. I would start from my lab, which is sensor and VRT lab. And first, I would talk about one of the sensor that we have developed here in the center in our lab. It is the plant height detection tool. It is for researchers to assess the plant height. So in Pakistan, we are still sticking with the scales and to note down the plant height and different phenotype parameters of the plant. So we have incorporated GPS technology in this sensor system, and it is automatically recording the points that we are the sampling points and also the height of the plant for uh, for recording purpose. And then at the end, Excel file is provided that can easily give you the data that you have collected through the field. So this tool is basically designed for researchers use, and our team has developed the smart app for this specific tool or this specific device, and we are already in commercialization phase of this technology and providing the this device to some of the researchers on campus and also in other agriculture universities. Then I would like to talk about the smart specific sprayer, the 4S technologies. This technology is also working on the spot detection or plant detection system. So it is equipped with an ultrasonic sensors, and we are using, or we have indigenized the boom sprayer, the double-sided boom sprayer, the horticulture sprayer we call in Pakistan, with the sensing technology to make it spot specific. So this it is already in commercialized form, and farmer are using. So we are in terms of next phase of this technology, we are going to incorporate the camera technologies for making it also disease detection, and then to the mandate is to lower the application rates and apply only at the region where it is necessary. So in terms of testing it, we have tested in our orchards, and there is about 30 to 40% saving for using this sprayer. For the agrochemical that we have saved about is 30 to 40%, and it is significant when we are dealing with hundreds of acres of citrus that we are producing and exporting through Pakistan. And then the technology that we have also developed, and we are actually in prototype phase. We have already developed, and we are in process of developing it for the commercial phase. So it is the variable rate fertilizer spreader. So we are implementing again the prescription map based technology. So it is equipped with the GPS, of course, and then the program that is already a customized program that we have established in our lab. We are going to provide a GPS-based prescription map, and the electronically driven motors are going to dispense the rate according to the need of the soil and crop. And we have successfully tested this variable rate fertilizer spreader in prototype. And in terms of way forward, we have already procured or uh, we have already selected an industry that we are going to make it the industrial scale version of this technology. And then we are proud to talk about the auto guidance system that we have adopted. I know like John Deere and other technology, other tractor providing companies in States and Canada, they have already they are equipped with their own GPS technologies and auto guidance systems. But in terms of Pakistan, uh, we are the first one to introduce the GNSS based auto guidance systems. It's a Chinese variant that we have installed right now, and we have installed on a local Massey Ferguson tractor. We have the low HP tractors here, so it's about 85 HP tractor, and we have successfully tested it in different cropping systems. And the initial results that we have got from using the auto steering technology that has increased the wheat production about 10%. So which is significant since wheat is our crop for our food security and somewhat national security as well. So here are some of the results that we got from the auto steering technology, and then without the auto steering technology. So uh, the as I mentioned earlier, about 10% of the uh, yield was increased using this technology. Then the challenge that our farmers are facing is because our tractors are still like very old style, or I would say 80s or late 70s models, and we are the challenge is associated with the depth control or implement control. So we have developed a device we call it seed depth monitoring system. So the drill is equipped with this ultrasonic based system which detect the which automatically detect the height of the seed placement, in depth of the seed placement, I would say, and then it provides a guidance for the farmers to lift or lower the implement behind the tractor. So the again, it is used. The benefit of using this technology is that it increases the yield. It provides a better germination since we have a better seed placement below the soil at a uniform depth. So in terms of arid region, we are shifting from broadcasting, which is like very traditional technology, to this drill technology. And using this technology, farmers have uh, got the initial results that we have got from farmer surveys, and the farmers who are using this equipment is about better germination rate of about 8% compared to the traditional technologies. Uh, I would like to play a video of the auto steering technology that we have developed. We are using it for spraying purposes as well as for the seeding purpose, and also for the tillage purposes as well. So this technology is indigenized in various formats. So now in the next phase, since this was the straight line sowing mechanism, in the next phase we are developing, or we have actually working in a collaboration with a Chinese company to indigenize these auto steering technologies for Pakistan. And also we are implementing a solution that provides an auto turning at the edge of the field. So that would be our next mission for the auto guidance system. So now moving from VRTs to UAVs, uh, we have different type of UAVs at our center. This is right hand image shows you a M600 DJI drone for crop monitoring. We are using it. We are using this drone and other monitoring drone that we have in the lab. They are equipped with the multispectral, hyperspectral, and then we have also thermal sensor. And quite recently, we have also procured a lidar, and we are using these sensors for different type of crop phenotyping, and also looking at different vegetation indices to monitor the crop, and also the pest movement across the field, and also predict the yield. So the next phase is to integrate these vegetation indices that we have developed with our big data aggregator repository through the decision support systems to provide the guidelines and the monitoring services to directly to the farmers. We are also using satellite products. So our mandate is to provide timely information to the farmers across Pakistan. And then we are proud to say that we are the first one to introduce the drone spraying technology in Pakistan. And we have master in terms of evaluating and adopting this technology in Pakistan and propagating in different regions. We have about 7 different type of spraying drones, and which are Chinese, again heavily, and then Korean drone, and we are also have the state of the art XAG drone from China as well. We are using it for evaluating the drone technology in different cropping system. And in the way forward that we are working with the farming communities to work on the different crop and pest diseases, and equipping these drones with different sensing technologies to apply the spot specific spraying using the drones. So since it's a non-destructive mechanism of spraying and it's a water saving mechanism, so we and the since we are in terms of this shrinking of the spraying windows during the season, our farmers are using knapsack sprayers and boom sprayers, so which is very time consuming compared to the drone technology. So recently the government of Pakistan has also, we shared the results, and they are also establishing the drone spraying technology centers across Pakistan now. And we are also working closely with the SIFC on this avenue. We have also procured a XAG P100 drone. It is a fertilizer spreader drone, and it is also used for seed spreading. Uh, as you may know about the recent flood that happened in Pakistan. So the mandate or our center was to spread the seed of different grasses and different lentils crops in the flood affected areas, which are otherwise arid or desert areas, and then to get the crop or develop the rangeland in these areas to for providing the food in these flood affected areas. So, and then now we are using, recently we are doing research on using this fertilizer spreader drone on different aspects as well. Here are some of the highlights again of UAVs in different regions of Pakistan in different cropping systems. So we are also working closely with the farmers that are registered with our center and providing them these technologies at the farmers levels. And then moving to the digital agriculture lab, the digital agriculture lab first product they are working on is a crop phenotyping card. It is equipped with the cameras and then a computer system, a laptop device, especially a ruggedized computer, to get the imageries of different weeds and disease affected plants in different cropping systems, and develop the AI-based libraries for those. So we have our customized this vehicle or this cart, and then we have also developed a customized program for developing these libraries. Dr. Tahir and Dr. Akib is lead in this lab, and their lab is basically since they have developed these libraries, they have also developed a prototype of a sprayer that is applying the pesticide according to the uh, like on a spot specific basis. When it detects the weed, it applies the pesticide. So huge saving in terms of saving, it's about more than in some fields that we have tested, since it's a prototype model. So in potato that we have established the lab, it's about 30 to 40% saving. And then their lab is also working on the yield estimation for different crops. Here, the results of some of the work they have done in potato. And then the crop monitoring devices, crop plant canopy measurement devices that they have developed, the customized program again for it. Now, in the phase two, they are developing a 3D based model using a customized program based on the sensing system. And some of the plant disease detection app that we have already developed in the center and farmers are using. It is potato for 5 different crops, and it is say, as I mentioned, that farmers are using for different type of disease detections and pest detections. Some of the other apps that we have, the data management app for plant tissue culture. And moving from digital agriculture to mechatronic, uh, we have we have developed indigenized robotic arm for a controlled environment in our center. Engineer Saddam Hussein, who is also working now with Dr. Heyman here, so he was a part of this team who have developed the robotic arm, and the mainly focus is to, since importing these items and also is very costly, and then our agriculture is different from in terms of field scale and also in control environment from the developed countries. So we have to stick with with our localized or indigenized version. So our center is also working on developing this robotic arm. It's a since it's a robotic it's a remote control device, RC controlled, and we are now mounting a camera, a depth sense camera, to shift it to an completely automatic robot for the fruit harvesting as well. And then in terms of control system, we are working with the farmers who have developed who have the hydroponic systems, and we are installing the smart monitoring or control systems to their hydroponics. We have on campus about the largest hydroponic facility in Pakistan, and we have also developed an indigenized system to control the environment inside this greenhouse. Then talking about the soil and crop monitoring lab, since everything starts from soil and then the crop. So the variable rate technologies are, especially the fertilization technology, are based on the prescription maps. And then we have the different soil sensors, and we have some of the indigenized soil sensor that we have developed at the center. We are using it to develop the management zones in different cropping systems. So it is we are, as I mentioned earlier, we have also working on developing the prototype or the industrial version of the variable rate fertilizer spreader. So this will be, these maps will be, are the essential part that are being used in those variable rate fertilizer spreaders. So moving forward, we are planning to shift to web-based zone management. So we are going to conduct these field surveys or soil surveys across Pakistan, and during the crop seasons, all the farmers that are integrated with our systems will get the prescription map, and then the center that are associated with our national center are going to provide the application, the variable rate fertilizer application to those farming fields. So here are some of the work that we are doing in potato and other cropping systems, and some of the zones that they have delineated. The other mandate of this lab is to evaluate the different high efficiency irrigation systems. Since we are water scarce region, and also in terms of agriculture, Pakistan is facing the challenges of water scarcity. So our center, through our the smart farm that we have established, and recently the farmers that we are working with, we are evaluating these different high efficiency irrigation systems and equipping these systems with the sensing technologies to remotely monitor the variation in the soil moisture and crop health, and then apply the irrigation according to the need of the soil and crop. Here are some of the results, and then moving to the last lab, we have as I was mentioning at the start of the presentation, we have the first big data agriculture monitoring station. So we are working with the Sparco, which is the space agency in Pakistan, to provide us some of the imaging satellite products. And through the sensing technology that we have installed in the field, we are we have the big near to supercomputer, but we have a big high efficiency computing system that we have installed in our center. We are developing the AI based and ML based solutions for applying the agrochemicals according to the need of the soil and crop. Here are the smart farm that we have established at Kunt, and the results, the initial results of testing these smart technologies, these sensing technologies in the fields that we have established, we have increased the crop productivity of about 20%, 25% in the different cropping systems, in three different cropping systems: peanuts, potato, and wheat. Uh, Here are some of the highlights. And in phase two, we are developing the decision support systems and app that we have already developed, but we are developing a commercial variant of it. And then since we have developed only two farms at right now, so and we are working with about 20 farmers across Pakistan. So our center is looking forward to work with the government to implement the smart IoT solution in different regions across Pakistan. Here is the smart app, IoT app that we have developed in the center. It's a customized app, Android-based app. And now the part that where we are providing the trainings and the capacity building of different researchers. Here are some of the highlights of different uh, KTT activities, knowledge transfer and translation activities that we have done across Pakistan. We have trained over 300 HQPs and provided training of different variable rate technologies to over 200 farmers, and provided the guiding document for drone adoption for civilian use in Pakistan. And we are cooperating with different regions, North America, Europe, and East Asia. With the We are part of the CPEC, and we are working with the Chinese, especially on drone technologies. And uh, then the Koreans, this is the our collaborating partner from Dalhousie University, Dr. Ahmad Al Malahi. So he is also working closely in terms of some of the transfer of these technologies to from Canada to Pakistan and Pakistan to Canada as well. And then recently we are working with the Koreans to propagate the drone-based solutions. So in the Korean drones for spraying purposes in Pakistan. And then some of the visitors from the French delegation recently. Here are some of our partners, the local partners, and then some of the industries and the startup programs, some of the commercial banks, and are some of the international collaborative partners from Canada. So at the end, I would like to thank everyone for providing me the opportunity. And I am open to any kind of, or our center is open to any kind of collaboration. And I would be happy to answer if you have any questions. Thank you very much.
Thank you very much. Any questions? You can jump in and ask your questions, or if you wish, you can also type in the chat box.
Hello, hi.
Yes, you can go ahead, Gil. Before that, you wanna say? or if you have question, or if you say anything. Dr. Evans is our center director. Yeah.
Right, yeah. So I just want to say hello and happy to meet virtually. We are looking forward, to meeting you in person one of these days pretty soon. And thanks for taking the time out to share all the exciting sort of research you guys are doing there. Certainly we'll complement some of what we are doing here. We look forward to, collaborating with your center. As you know, we have the paper in process right now, so I'm still checking on it to see how it is progressing. But I enjoyed your presentation and all of the exciting things that you guys are doing there. So look forward to further collaboration. One thing, if you could probably tell me, and I stepped away for a little while, so I'm not sure if you shared that information. But in terms of the budget for your center, or what is an idea of the budget that you have to conduct that sort of level of research?
It's about so right now we have about 6 billion Pakistani rupees, which is about if I translate into the dollar, it's about $2 million. So that is the university budget for in different in 3 mega projects that we have, and we have the collaborating agencies which I already mentioned, the Sparco and PF. So they are also taking share from some of these funding as well. So in terms of local funding or the university only funding, it's about million for developing these technologies, $1 million.
Well, that's impressive, yeah. And of course, the whole AI issue is where the University of Florida is also going on. We have some of our faculty who are doing some cutting edge research along those lines. One other quick follow-up is, how do you determine the priorities or the areas that you will conduct the research on? Who makes that decision? How is it done?
So Dr. Evans, it's about usually since these were the government funded projects. So in terms of the RFPs or the proposal document that we have submitted through our universities, we have already highlighted the deliverables for these projects. So those deliverables are automatically translating into the mandate or our center. But then in terms of now moving forward, we have a strong team, as I showed earlier. So our team decides to allocate the budget for certain sections or certain segments that we are developing, especially focusing on the need of the farmers and the need of the government as well, that they are shifting since they are adopting these precision agriculture technologies. So now our main focus is not only on evaluating or implementing, but also on the developing side of these technologies as well.
Okay, right. And the final thing, not to take up all of your time, but a lot of the technologies that you share and those development are not scale neutral. They're mainly for large farms, right? A lot of the ones that you discuss is really for real large farms.
Yes, this is the common question that we have. So just to share with you, about 70% of farmers has a land holding of less than 2 hectares in Pakistan. So in terms of land mass, about 50% of the area that is under cultivation has a land holding less than 4 hectares. So this is the challenge that Pakistan agriculture industry is facing. But the solutions that we are providing, we are propagating it through the servicing industry. So at a village scale. So the model that recently we pitched to the government is to establish the servicing stations, the local servicing providing station to the farmers who have the small land holding. For example, drone technology, I would start with the propagation that a local farmer or a local business owner, they procure the drones and they are providing the services to these small landholding farmers. And they are spraying, and they are super busy. Like usually one drone is enough for one village. So for the spraying purpose in different cropping systems. So, and then the laser land leveling is another prime example of how the servicing industry is successfully implementing these technologies at a farmer level. So hopefully I've answered your questions. Yeah,
Right, so thank you very much. Okay.
thank you.
So if I may ask a question, I'm sorry I joined a little late because I had to give a lecture, but the navigation system you talked about, the steering system, what are the requirements for the tractor's capability? Obviously, they must be power steering, or are you concentrating on more finding the path than actually implementing on tractors?
Thank you, John. First of all, I've read your papers, so it's nice to see you in person. So the tractor that we started with, we have power tractors here. It's not like very uh, good compared to John Deere and case, but it's reasonable. It has a power steering system. The issue that we had, this first auto steering we installed on a two-wheel drive tractor. So it was a rear wheel. And the challenge was to keep it on track. And we had some errors. But now we have installed recently on a four-wheel drive tractor, and the results have significantly improved. So we are also working with the tractor industry to make a bit more user friendly or farmer friendly, like modification in tractors to for the implementation of these technologies.
Okay. So the floods you had were very severe, and in a is the anticipation that that was a sort of once in lifetime event or once every 10 years, or do you think it's a consequence of sort of weather changes occurring in your subcontinent?
Definitely the last one, later one. The heaviest flood we had was in 70s, then uh, early 70s, then the 90s, and then we are now, since this new millennium, we have about like four major flooding events that has a 100-year return period. So it is quite significant in terms of the due to this climate change that our country, especially the region that is near to Himalayas and Karakoram, so we are at the footsteps, right? So our agriculture is like worstly impacted by these climate change event, that especially the flooding, and then some region has severely affected by the droughts events as well.
We have one question in chat, through chat, from Dr. Lee. He's asking, what kind of soil sensors are you using for soil fertility monitoring?
So thanks, Dr. Lee. We are using a Chinese sensor. It's a JXYT sensor that is used for macronutrients. It's especially NPK, and then it provides also like 7-in-1 monitoring. So we have NPK, soil moisture, ECPH, and then the other temperature of the soil. It is we have challenges in terms of calibrating, so we have developed the calibrated solutions for and it's in terms of its proximity, it's about 80 to 90% accurate compared to the standard readings.
For all elements, including phosphorus?
Yeah, including NPK as well. Yes. but we have to calibrate each time we are installing. So we need a regular calibration of these sensors.
Okay.
Yeah.
If there is no other question, I have one question. So it's very interesting when you discuss about the service village and how one drone can provide service to the entire village. Can you elaborate like the kind of infrastructure that's needed for not only for image collection, after image collection do they take image collection or just go and spray? How do they do it? Like
So right now they are spraying just like in terms of regular spray. So they are just replacing the knapsack, which is like a manual like person spraying, and also the boom sprayer with the drone sprayers. So, but I would see like hopefully due in the near future, they would use the uh, services that are provided through the crop monitoring and implement the smart spraying systems. So, but in terms of availability of sprayer drones, right now we only have the uniform spraying drones in Pakistan.
okay, they don't collect any data and no need for processing. Okay.
Oh, they are doing, so they are doing they are collecting data. They are providing it for water monitoring or yield estimations only. So they are not using it for pest spraying or disease spraying.
Did you say for water monitoring soil moisture?
Yes, they are using the especially the satellite products and use it for water stress, like the stress due to the irrigation. So for in terms of like estimating how many irrigations are required and when it is required. So, but very progressive farmers are using these services. So if you are asking me that local farmers or at the large scale farmers, are using it? No, they are still using the old traditional technology of flood irrigation.
Any more questions? All right. There are no questions. I think we can end it here, but we'll continue the discussion and communication and see if there will be you know areas we could collaborate. And again, we would really like to thank you for taking the time to give us a presentation today.
Thank you very much,
Yeah,
all. Thank you
good
very
job.
much, Dr. Evans. Yeah, thank you very much for providing me the opportunities. Have a good day.
Thank you. Bye-bye.